Hi there, what's up? Today we will demonstrate how we can resize the LVM uh, LVM volume of Kali encrypted system with LUKS encrypted. So when full disks are encrypted, full disk that assume I can assume that if you had 500 uh, gigabit of disk and you would use all of it for the Linux machine like I used for Kali. So what in my real environment I used it 500 gigabit for Kali, and this is not real. This is virtual environment, virtual box. So if you need to increase or decrease the spaces of that partition, you can easily do. um, I wouldn't know about from about it's about 2 3 years I was trying to know that, but I didn't know. But currently I know, and I thought that it would be easier for me to share the knowledge which helped me convert that all like from reducing and increasing the space of that full partition. So here is the steps I am going to share you that can help to create that. First of all, let me show that this is my current system, and it is okay. I had already had many things, like it is currently 18.12 gigabit. Oh, okay, 18.12 gigabit of storage uh, in this. And if I'll df dash h over there, I can see that 18 gigabit is full disk size and 14 gigabit is currently in use, and available space is 3.3 gigabit. So I would create um, partition from 3.3 gigabit about 2 gigabit, something like that. Yeah, just to demonstrate how you can create a new partition on that. So you can install Windows on any other operating system inside that with uh, so this is my machine. So what first I would need is to actually reboot this device. And if you had a Kali Live pen drive, then you would put there that into the machine. But I would recommend that you first prepare yourself in a virtual machine. So that would be better, because I had did 2 3 times in virtual machines, then I would do in my real environment. That would makes that I would have experience of a virtual machine, so I would easily and without any error I have done in my real machine. So first do that, make bootable of device, and then reload that. Let's me now I did have Kali Live booted. Then what I did is open that machine, and it would take a moment. Okay, this is Kali Live. As you can see, the default username and hostname sudo sudo. Now it's the root user. Now what I do, first I check the partition which is on that. So let's see, this is the partition, the dev dev sdf5. This one needs to be resized and resized, and it is currently encrypted, so I cannot resize at current time. So what would I do is first I would do c rypt crypt setup LUKS open dev SDA5. This is where encrypted drive is, and then I'll give Kali CRYPT Kali encrypted. Enter your password. This is our first command. Crypt setup looks open is our key to the encrypted drive. It takes the physical partition like dev SDA5, prompts us for our password, and then creates a temporary decrypted virtual session of it that can be understood. We're naming the unlocked version of that is Kali encrypted, and it will now become accessible using div mapper directory. As you can see, that is div mapper here. It is available. So now I need to do is vgs scan mknods node. What does this do is now that the container is open, we need to find the LVM inside it, and VGA scan does exactly what it says. It scans for LVM volume groups, and mknode flag is curical habit. It ensures the system creates the proper device files or nodes for our volume. This prevents error when where their systems can't find the volumes we want to activate. And after that, I will do vg change dash ay. Once VG scan has found our volume groups, VG change dash AY activates its AY stand for activate yes. This command essentially flips the switch and brings our logical volume like root and swap online, making them visible to the system and ready for us to move. Uh, Now what I need to do is to check that file system is e what is it, e2fsck, if e2fsck dash f div mapper kali crypt root, and this would check for any error like safety. Before we change any size, we must ensure that our file system is healthy. E2fsck is the extended file system check tool. The F flag forces a check even if the disk seems clean. This command will find and fix the minor errors, which is absolutely mandatory to prevent data corruptions during resize. So if you we need to fix that, I would say yes, yes. And this could be many times, not 2 3 but 5 10 even 20 times sometimes, if and could also be not at all time. So it would be like that. And after that, I would do is resize to file system dvm mapper, then kali crypt root. I had there is like 18 gigabit. Then I would, let's see, create a 16 gigabit file. let's let's and like 16 gigabit is the volume which I would reduce from 18 gigabit to, and what it does say that it is now resizing the file system of dev map kali root block. The file system is now this block long, so it is actually correct. Yeah, it's correct. Then what it does is, this is where the real shrinking begins. Like resize to fs modifies the size of files, the ext4 file system itself, the innermost layer. We're telling it to shrink our root of file system down to a new specific size, which is 16 gigabit. We are making the content smaller before we shrink the box there in it. So this is what it does. Then I'll do lv reduce dash l. It would be 16.1 0 G, and dev mapper Kali crypt root. It says that size of a logical volume Kali crypt root changed from 18.12 gigabit to 16.10 gigabit. Next, we shrink the container for the file system. The logical volume LV reduce does exactly that. We use the dash L flag to specify a size, telling it to reduce to 16.10 gigabit gigabytes. Curical. This is slightly larger than our file system. Like, this is the new file system, which is slightly larger than this, which provide a safety buffer to ensure we will we were making, like, we don't cut off any data. Then the next command is pv resize. Pv resize div mapper Kali encrypted, and after reducing the logical volume, there is now empty space inside the logical volume manager LVM. PV resize, which stands for physical volume resizer. Yes, and clearly it detects this empty space and shrinks the LVM physical boundary to its smallest possible size. The officials, the officially, it frees up the space within the LVM, so it would do that. And then the last command for here is crypt crypt setup resize Kali encrypted, and then again enter the password, hit enter. It would do that, and we are nearing the outer edge. Just like last command, crypt setup resize tells the main loop encrypted container to shrink down and resize any internal empty space that we just created. This prepares the entire encrypted block for the final step with GParted. And now I can show that GParted over there. This is that, and now we can shrink it and resize it and enter the password, and it would after that it need to do once again. Okay, then it's created about unallocated space of 2.2 gigabit, which you can use to do any sort of thing, whatever you want it to do. Okay, let's see. LVS, now it's become 16.10 gigabit, as we mentioned over there at this line, LV reduce. And the final step is to VG change dash AN Kali crypt and crypt crypt setup LUKS close Kali encrypted. This is all the important fix for GParted. VG change means it activates no, which safely deactivates our LVM volumes. Then crypt setup LUKS close securely locks our encrypted container again by doing it this. Well, after that, the partition is no longer in use, which is great. And in between or after that, you can create the GParted as mentioned. And let's reboot and test that it works in the real environment. So I would have rebooted it. Enter the password again. It does have currently 1.3 gigabit as 16 gigabit is in size. And see, and you can see that GParted, there is a file system which is unallocated, which we did it currently. Now let's do that in reverse. And how we can do that all in reverse?